Oh, okay. That broke. All right. So, as far as being a testing, I lost my thread now. Testing platform. One of the first things you do when you want to run Arquillian is to select some type of container that you're going to run against. That could be some examples here being a Tomcat instance, a Wildfly instance, or a JBoss EAP, or Glassfish, or whatever. That's kind of the target environment that you want to run this or these tests against. Or it could be a remote thing like an OpenShift instance. And then when Arquillian starts up, it will then connect and communicate with that container. And based on how you set up the test, it will then start to deploy the deployment that you have defined, the target, the scope of this test, essentially, the application that you want to test that's being deployed to the target environment, along with a bunch of Arquillian things. And then you can then move the whole test execution over into that runtime instead of having it or only having it run inside the Eclipse IDE. Now you have the advantage of actually being inside the runtime that you want to test. That gives you the advantage of actually having access to all the things that runtime provides, like security managers, entity managers, data sources, JMS connections, and all of those type of standard things. And when Arquillian then is done running the in-container test, it can then move the test results back over to the client side, and everything looks like it were if you ran a normal JUnit test. And then, of course, it cleans up the environment. So that's the basic what Arquillian as we know it from the Java EE space does. And this is what the JUnit version of that test would look like. So you have the JUnit extension point that says hand over the execution process to the Arquillian runner. At this point, Arquillian has control. It can do essentially whatever it wants. One of the first things it does is to look for that deployment annotated method, and relies on a library called shrinkwrap to bundle up whatever you want to deploy to this application server. So you can add the classes, packages, files, full jars. You can resolve them from the Maven repositories and so on. Then it attempts to reuse the component models that exist in that environment that you're targeting. In this case, we're using CDI, so we can inject back the live bean that is actually being deployed and running in the server. It's not a mock, it's not a proxy of some sort, it is the actual thing that the server operates on. And then you come to the test method, and the test method executes as any normal JUnit test, essentially. You get the values and you assert on the state. That results in that result is then being handed back down to the client. That was the in-container version. This is the client-side version. There's kind of 2 points. There's the interest of being in the environment that you want to test, and then there's the point of being on the outside of the environment because you have remote entry points, like a JXRS service or a remote EJB or HTML pages or whatever. The only difference from Arquillian point of view is that you then set that the deployment is not or is testable false. And so Arquillian won't do anything besides deploying this for you, and then you're up and running. And then you can, as we're using here, we're using the rest assure library to communicate with one of our REST services. So to set it up, for those who have used Arquillian in the past and a bunch of the extensions, we know that it's a bit complicated to know what works and what doesn't necessarily. So we started something called the Arquillian Universe BOM, which includes all of the different extensions and try to align the different versions so that everything should work together. So instead of relying on the Arquillian BOM, you can now rely on the Arquillian universe BOM, and you just follow the same pattern, being org Arquillian universe and then the name of the module or extension. So in this case, we want to use the Arquillian JUnit integration, but it could be the testing integration, it could be the Cucumber integration, the Spock integration, or any of the other test frameworks that we support. And then, in this case, we're using the Chameleon container, which is a proxy container, essentially, to allow you to call all the other containers. So there's one dependency to include all of the different JBoss versions and the different Glassfish versions and so on. So let's see that up and running. That's the basis of Arquillian. So this is the same test that we were seeing on the slides, the in-container version. And as far as it's being configured, we can see in the POM here that it's just relying on the universe BOM. Oh yeah, it's a bit small maybe, but and the Chameleon driver. Let's see, and it's defined in the Arquillian configuration file that this should be running on a Wildfly 9 managed server. And some of the features of Chameleon is that as long as you haven't defined where this server is, it will actually download it and extract it for you. It makes it easy to demo essentially and to run from CI systems and so on. So since this is just a JUnit test, the only thing we need to do is to right-click and say run as JUnit. Run as JUnit. It's starting up the server, deploying the application, and we got a green bar. You can look through the log and see what's happening, but it's not that interesting. Do people understand the conceptual of what Arquillian normal does? Any questions around that? Maybe it's asked the other way. Is there anyone who understands it at all? 2, 3, okay. All right, I can explain more. So what Arquillian does in the background here is kind of the first steps that we looked at. So as far as you have defined Arquillian, it will then look for the deployment. It will start that container that you have configured, which is, in this case, the Wildfly container. We start that as part of the test hive cycle. Then it will deploy the deployment, and then it will move the whole execution of the test over into that container. So you're running inside that container. Now, that's the wrong test per se, but this one, we could actually, for the fun of it, let's see. Let's start up a Wildfly server outside of Arquillian's control, and then change it to use the remote adapter, so they will communicate with some existing server, and we can debug that server. And let's see. When we then run the in-container test, we can set a debug point on the inside the test method and see where that actually executes. If we rerun that, see it's not starting it up anymore. Wait. Come on. Then we have a breakpoint, and we can see the actual breakpoint, the stack of it, maybe a bit hard to see, but it's coming in from the HTTP server on the wildfly side. So it's actually not executing in the IDE, but the request is forwarded and executed in the remote environment. And then it's being passed back to the client, so it will see and feel like it was executed as a local test, regardless of it being executed either in Eclipse or in Maven Surefire or whatever. So, let's shut that down again. Cause trouble. That doesn't work. So the principles around Arquillian in general is the test case itself shouldn't have any information about where this is running. It should only define what it needs to run. That to be able to create portable tests in the sense that they can swap between the different environments. You have the same test case or test suite run on both Glassfish and Wildfly and see that they work in the same locations. And it's going to execute from wherever you want it to, being in IDE or Maven Surefire, for instance, or Cradle or whatnot. Some of the big problems that we're trying to solve was the big integration test suite type of thing, where you end up writing a test, going to Maven, having to build the whole thing that can take an hour, and then you're going to have one failing test. So we wanted to be able to be in the IDE and just code the test and run that single test as if you would a normal unit test. And we achieved that somewhat through the use of the shrink wrap libraries, which can use the incremental compilation that happens in the IDE and just package up the stuff instead of having to go through the whole Maven build. And we call it a testing platform instead of a testing library, because it's really what it does is just to manage the lifecycle of different things you put on top of it. So it manages the lifecycle of Selenium, for instance, through the drone extension. It handles the lifecycle of containers with the container extension. And it can be used from multiple different testing frameworks, or it can be used as a standalone thing outside of a testing environment. And it's built to be flexible and extensible in the sense that we don't know what libraries or component models we need to support today, or we know which ones are here today, but we don't necessarily know which one come tomorrow. So it's built around extensions and enrichers, so the platform can kind of stay the same, and you can just kind of evolve it along as a modular system. So we're going to look at one of those extensions today, which is Arquillian Cube, which is the extension that operates and controls the lifecycle of Docker containers, which is the basis of this talk, essentially. So Cube is, as I said already, it manages the lifecycle of a Docker container or multiple containers. And it has some magic, so you can either use just the Docker containers as is, or you can map up a container adapter from the Java E world on top of a Docker instance, and Cube will kind of handle all the IP addresses and port mappings and all of that stuff for you. So you just say, on that Cube there is a JBoss server, and then Cube figures out the rest. And of course, you can operate multiple containers at once, and then kind of orchestrate how they run together, how they're started, and when you want to stop them, etc. And it's not just built around the idea of being an application server inside a Docker image, but it can be used with any library anything that starts a port, essentially, any language. So drop wizard, Spring Boot, Netty, Node, VertX, Bash scripts, I mean, whatever you want to make. To Cube, it's just a Docker container. So we're going to look at the first test. Kind of some of the premise of this talk is to see how we can use Docker to enhance our current testing techniques, as well as how we can test in general Docker stuff. So the first test here is a simple Wi-Fi-based Docker image that is custom made and opens up all the management ports and so on. So we're going to use Docker as a, it's not a pre-configured image, but we're going to change the state. So it just starts up a Wi-Fi server, and we're going to be deploying into it, as we were doing in the other example, but this time we're going to do it through Docker instead. So the test case itself, we're also going to use an extension called the Arquillian Persistent extension, which helps you deal with database data, essentially. So you can say, before this test method starts, we're going to insert this YAML file with data and make sure that the state of the database is correct. And then we're going to execute these different JPA queries against it and see that the results are as expected. The only thing you have to do when you're using the universe bomb to get Docker in there is to add the Arquillian Cube Docker dependency. And to the persistence is Arquillian Persistence. There's a pattern here in how things are named. And then Arquillian Chameleon. So this is the Arquillian XML file when you're using Docker, Cube. There's an extension section for Docker. In a minimalistic, there's a bunch of rules. It will, if you don't define anything, it will try to figure out where it might run this thing. So if you're on a Linux box, it will look for the Linux, Unix Docker socket. If there's a Docker machine up and running, it will see if there's only one running and that kind of thing. So it tries to kind of figure out where it should run. But in this case, we're telling it to run on the Docker machine that's called dev. And then there's a definition of the image. So there's an image called Wi-Fi. We're going to use the Docker file that is located within our project structure to build this file. To build this image as a part of the test run. And then there's a couple of port bindings, fairly standard Docker stuff. Due to how Wi-Fi works with the authentication mechanism and so on, you have to set up some user as long as you're not running on the same host. So that's why these two are there. But as far as the Chameleon configuration, it's just telling it that it's going to use a Wi-Fi 9 remote adapter, and combination of Cube and the Docker integration will then set the IP address that it's going to use and look at the port bindings, for instance, that you have remapped the default 8080 port to be 8081 and kind of update all of that configuration for you. So let's see how that looks. So yeah, right. So this, as far as the JPA part of this test, it's going to run against the default installed what was it called? The default database, example database. What is it called? H2. Thank you. H2 and nothing else. So it's all internal and all inside the same image. Test case itself doesn't really. Is that the right one? So the test case is the same as we saw. Just do run as JUnit. And now if I find a little window here, you should see here, well, it's unclear now, but now we're inside the dev Docker machine, and we can see that the wildfly image has been started up. It's been up for 9 seconds, and there it's starting to run the test. And we should see the Docker image go away. And boom, gone. So that's the most simple version of Kube. You have starting up some existing container in some existing Docker image, building the image when it starts up to match your, I can look at that as well. So we defined here, we had the Arquillian XML pointing to our local folder here that has all the Docker file and what that's needing. Essentially just setting the password and closing the ports.
May I ask a question?
Yes, absolutely.
The file that defines containers.
Mm-hmm.
It contains some YAML format. Is it something that you are defining for the code, or you are using the specification defined by your project? Because your is solves this issue like orchestrating containers. So are you using their format, or do you define your own format?
The format that you saw here was our own, essentially. It's loosely based around Fig and how the variables that the Docker service that takes in. That essentially what that's based on. But we do also support the compose format. The compose format came after we started that thing. That's why that's not the default option at the time. Can test runs without exposing the ports? No. No. You technically could. They would only work on the local host, essentially, because in a normal remote machine, you wouldn't see the container's IP at all, most likely. But running on local hosts, you could do that. You could configure it to run directly on the container without going through the hosts, I believe. That's possible. So I'm going to look a bit on the orchestration part of it. That means several dependent Docker containers that needs to be started, and some of them needs to be started up in a different life cycle than what the test container is going to start up in. And you can compose them based on different templates that kind of extend each other. So as far as JPI part of this, we're going to use Wildfly. It's going to be the same test case as we saw before, but this time it's going to be configured to run against a MySQL instance instead, which then is 2 different Docker containers. Configuration doesn't, the basic is still the same. There is now a property that we have exposed that says auto start containers. You can put an expression there to say which of the defined containers here, either the Wildfly or MySQL latest, that you want to start up before, essentially before anything else happens. And then we are adding a link so that the containers can kind of see each other based on the name. Now, based on the property there that you see, say which one you're going to auto start, you can have multiple different MySQL images, for instance, that have a link. So it could be a MySQL 5, it could be a MySQL 6, it could be a Postgres, and just based on swapping on which one you start first, essentially, is what will define which link the Wildfly server will see and which database you will be running this test against. Yeah, and that allows you to fairly easily spawn out multiple different tests over multiple different database servers and so on, which is an interesting thing. So, right, to your point, I guess, or to some of it, that format is the Arquillian cube format, loosely based on Fig and some other options, but it looks fairly similar to how the Compose format looks. So we also support the default Docker Compose format. So you could, I mean, that would be the version of the same configuration, but done in the Docker Compose format instead. And you just define that you want the definition format to be Compose. So let's look at that. So again, this is the same test that we saw before. We can just run as and we should start to see some MySQL containers starting, Wildfly starting. There we go. Green bar. That was with two containers, just splitting up the same example as we had before, but now over two containers, and Cube dealing with both of them and should have stopped both of them as well. Any questions around that? Yeah. Well, you could, let's see. You could technically in this file, you can define, instead of this property, you can say MySQL, for instance, and then you can say Wildfly. But if you just say Arquillian Cube, when it tries to determine this order, it will look at the links and so on as well. So it will start things in parallel if it can, but if it needs one to be started before the other, then it will, yeah, make sure that MySQL is up and running before the Wildfly one starts, for instance. Basically, based on which containers links to which, essentially. That's how it figures it out. Okay, that was orchestration. Containerless. So containerless is what a Arquillian container is, but for a Docker. So you can deploy Docker images, you can deploy templates, you can deploy it into a Docker host, essentially. And that's where all the other alternative languages and servers come in. So you define that to be the kube containerless extension. You want to add that. This is our JavaScript application. Just has a simple REST API, not too fancy. And then in the same fashion, we have the deployment method, but in this case, we're actually deploying the Docker definition instead of a Java application deployment to an app server. And beyond that, we kind of have the same testing abilities moving down. So there's a Docker template instead of a Docker file. And I think the only variable we support per now is the deployable file name, which is the content, or which is the tar file that's the output of that deployment method. So if you want to dynamically build up some kind of files to be added and automatically build as part of the test suite. So now you can sit and hack in the IDE. You can make changes to the JavaScript application, start up the test case. The image will be built with the JavaScript files from the IDE, and then start it up. And yeah, that's essentially the same as far as the configuration, except that now you have a containerless configuration instead of the chameleon one we saw before. And the cube format is the same. Just to see that runs as well. Does the npm install? Ah, we're done already. Or maybe not. What's happening? Oh, there's an npm start, right. And here we're done. All right. So that's just a pure JavaScript application as opposed to a Java app server or anything like that. So that could be a Python application, it could be whatever. Running a bit short on time. Whatever now, 2 minutes or something?
7 minutes.
Oh, 7 minutes, okay. So I'm going to drop the last demo and I'm going to show something that's brand new. So new that it doesn't actually work yet. So some of the advantages when you have a containerized system and you're controlling all the servers essentially, all the different Docker containers, is that you can also start to fiddle with the network and you can do all of these kind of magical things that you really haven't been able to test very easily unless you have some kind of VM system. So the new extension to Cube is something called Cube. Q from Star Trek, also know that is the entity that has control over all space and time and everything, right? So that's what a Q essentially does. Q intercepts your normal Docker composition setup and inserts proxies in every possible fashion. So when you should have been reaching your container, you actually be communicating with the proxy, and then it comes to your container, then that container talks to another server, but there's a proxy in between. So now you have control over all the different endpoints. So that allows you to do things like this, for instance. You can say Q, when this block of code executes, make sure that server 1, which is our container, any communication that happens on port 8085 will time out within 5 seconds. And then you can see, did my database driver actually handle that correctly? Did my REST service reconnect and so on? So we can run this now just to see how that looks. It still just ran as a normal test case. It's a bit small probably, but you can see the original configuration on top. We have 2 servers. There's one server that communicates with the other, and then the proxy comes in and kind of overrides all the communication between them to go through itself, and then you can programmatically control the communication flow between them. So we got a connection. He set exception because we told it to essentially do that. But of course, you have other options on Q as well. So you have you can set the bandwidth. You can tell it to be just down. You can set the latency. You can slice up all the package into much smaller bits, and you can have a very slow close, for instance, either on the upstream or the downstream connection. That's kind of up to you. So that gives you an extra level of control. Okay, we dropped that one. No time. So what's coming? Kubernetes and OpenShift 3 support we have kind of in the latest alpha releases. More work will put into those. Also around Core OS and Mesos as well. So Kube is essentially the Arquillian abstraction that deals with anything Dockery and the control over those. Skip that one. So if there's any the next steps as far as figuring out what Arquillian is and be a part of Arquillian is to go to the Arquillian.org website, which has a lot of guides, etc. Or you can join the discussion on discussion.arquillian.org. And any questions are welcome, of course. Anyone have any? And yes, that's me. Yes. What exactly? Well, as far as the integration there now is, it's you can use the containerless container as we saw before. You can deploy a Docker image that you build or that you're creating locally, push that to the OpenShift instance, which will build that and start it up. That's one phase. And then the other one is to start and control pods, whichever pod you want. And yeah, and essentially do the same thing as you see here, or that you saw here, is to some extent works in OpenShift 3 now. OpenShift 3 will also add on a bunch more stuff to it, so you have more control over communicating through services, setting up routes, and all those kind of features as well. But the basics as far as starting up an image on OpenShift, starting up multiple images on OpenShift, doing the orchestration parts of it, and also building something in OpenShift is also functioning as of Alpha 6 or so. Oh, yes, scarves. Scarves, right. Scarves. Welcome. Yes?
Does the Kubex tool work against Swarm?
Not currently. We haven't done anything against the Swarm yet. But that's something to explore. Then we're out of time, so that was me. Thank you for coming and listening.